Hi, so today I'm going to talk about our science project. Okay, this science project is given by Dr. Rabaa, who is our Physics 2 lecturer. So we form a group of 2 people and we choose a topic, Kirchhoff voltage law. So first of all, let me introduce myself. I'm Panum Checharan, anak perempuan Manon, with a metric number 173357, and my friend is.
And I'm Hashwini, anak perempuan Siramalu 173347.
So for this study or this science project, we have go through and we have watched some some video regarding Kirchhoff law from the YouTubes, and we have go through some books so that it can help to widen our knowledge more regarding what Kirchhoff law is and what we are going to study about Kirchhoff law. Okay, for your information, doctor, we borrowed the apparatus from the physics lab. So the lab assistant said we can just take the resistor and also the wire. So he just gave us, and we use that for our demonstration session. Okay, so we just get we measure the voltage or the current in the lab itself using multimeter. As we didn't use ammeter and voltmeter, but we use multimeter, which can function both. It can be ammeter and voltmeter. Alright, so we for these experiments or this study, we use a 9-volt battery and also connecting wires and three different values of resistor, which are 0.98 ohm, 3.83 ohm, and 5.63 ohms, and also a multimeter as an ammeter and voltmeter, as I mentioned earlier. For the methodology part, okay, at first the experiments was conducted by we set up 2 sets of circuit, which is in series and also in parallel. So for the series circuits, so the arrangements of the circuits is like we use 0.98 ohm resistor followed by 3.83 ohm resistor and the 5.63 ohm resistor, as doctor can see in figure 1 in our report. And after that, the circuit itself is connected to a 9-volt of battery as a source of voltage, and also the voltage across each resistor was measured using the multimeter, and then the currents that flow through each resistor was also measured in using the same multimeter, and the same step was repeated for the parallel circuit. So we are using the same resistor, the same value of resistor for the parallel circuit itself. So doctor can see in figure 1 and figure 2, that is our series and parallel circuit setup. So now we are going to show the demonstration. This is the series circuit setup. So we are going to determine the voltage of each resistor. So we are using a multimeter to determine the value of the voltage of the resistor. So for the first resistor, the value of the voltage is 0.41, and for the second resistor, the value of the voltage is 1.40, and the third resistor is 2.02, and the voltage supply was 6.54 volt. Alright, for now, this is the parallel circuit setup. So as the same thing, we are going to measure the voltage at each resistor. So for the first resistor, the value of the voltage is 3.20. Now for the second resistor,
The value of the voltage measured by the multimeter is 3.47, and the third resistance gave the value of the voltage is 3.50.
Okay, in this experiment, we have conducted to study the relationship between the voltage current in a direct current circuit. Direct current circuit is a circuit where we use a voltage supplier like battery, which is not an alternative circuit where we use a plug to supply the current. So, it is also to observe the resistance, current and voltage relationship in a series and a parallel circuit as we demonstrated before. Now, this is basically the application of the concept we studied in the chapter 6 of physics 2, involving the Kirchhoff law. In this experiment, as Panam said before, we used 3 resistors of different resistance and a battery which valued 9 volt. However, when we measured using a multimeter functioning as a voltmeter, we only get a reading of 6.54 volt, which means there's a loss in voltage where it is stated and the voltage measured. It shows the internal resistance inside the battery, and also it's a battery that we was used after we have used before for a different application. Thus, it's a old battery, so that may cause some effect too. So basically, our objective is to study the relationship, and the objective was achieved. As we can see in the result from our report, the relationship is similar with the concept where the resistance increase. If the resistance increase, the voltage increases while the current is constant, and the graph is plotted in the report itself. And for the parallel circuit, the objective achieved too. The resistance increased as the current decreased, and the voltage was constant. It's not a linear graph, but we can see a decrease in the current. Yeah, and we have also studied well about the Ohm's law, where we know voltage equals to IR, current times resistance, and the Kirchhoff law, where we study total voltage equals to 0 in a loop where the current flows in one direction and the total voltage equals to 0, and a junction rule where I equals to 0 at each junction. It's going to be a T junction, at least 3 points meet at that junction. Okay, as it is an experiment, there was some errors where according to the concept, the series circuit should have equal current across each resistor. But in this experiment, current at the resistor of 3.83 ohm had a significant difference compared to the other two resistors. Current at the other two resistors. While for the parallel circuit, the voltage should be equal. For the parallel circuit, the voltage should be equal across each resistor. But for this experiment, the voltage at the resistor 0.98 ohm had a slight difference compared to the other two resistors. Besides that, the voltage measured also different compared to the voltage stated at the battery. This might be because it was a second-hand battery. And another difficulty we faced during this experiment was lack of the circuit board. So we had difficulty to connect the wires. Okay, now I'm going to tell about few of the application of this Kirchhoff law. So first is the Christmas lights, where we can see it's continuous. If it is in series, then it's going to be spoiled if one of the bulb is not functioning. Thus, it is usually made in parallel circuit. Next, the chip in a PC that's usually going to be a series circuit as we stated in the report. The next application was house wiring. It can be either parallel circuit or series circuit based on its application and the current we going to use. And another common example is car headlights, which use parallel circuit to apply maximum voltage to give the maximum brightness of the bulb. So that's all the application, and I hope you guys understand what we have presented today based on the Kirchhoff law. That's all from us. Thank you.